to test-driven development. And so this is where we talk about the FHIR Testing Framework. And I'm going to go ahead and jump in here. So I'm Richard Ettema. So for those who were at the main session early on for the intro to FHIR, you should know who I am, but just a little bit more information about me. I'm a lead consultant with Aegis.net. We're based in the U.S., just outside of Washington, D.C. I am a FHIR certified implementer, and that's actually the beta program, the precursor to the proficiency exam that we have today with HL7. My background, 34 plus years in IT, 14 years in health information development, 4 plus years with the FHIR specification. So as I mentioned before, I started with DST1, it was like 0.08 version of FHIR way back when. Senior architect, lead developer for the Touchstone project, which is our tool that implements the FHIR Testing Framework, and I'm the author of our Aegis Wildfire public test server and client. So just a little bit about my credentials, if you will. So we're talking about test-driven development, and why is testing so important? Well, think about the airline industry. What would happen if airlines practiced what we call one-and-done testing? The only time that plane was tested is when it rolled off the factory floor. How safe would you feel getting on a plane? Probably not very. So how important is ongoing or continuous testing, especially with the airline industry? Well, if you think about that from a patient safety perspective, isn't patient safety also important too in our health IT implementations? So the question that I pose here is, how can implementations based on these industry-based standards, like FHIR, ensure that they're truly interoperable with each other? So there's a couple choices here. We could do expensive one-time, just before release performance testing, where we're probably likely to uncover some unknown performance issues, and we would probably introduce some unneeded risk and additional cost to the budget and so forth. Or we could moderate our expenses with continuous testing, what we call TDD, or test-driven development. So how many people here are familiar with the concept of test-driven development or? Okay, so how many Java developers in the house? Okay, you know what JUnit testing is, right? So JUnit testing for your software development. I like to think of this as kind of like similar to that, where we're doing a FHIR testing framework that's kind of like JUnit testing, but now at a larger scale for interoperability. So the idea here is that as you go through your development lifecycle, you infuse testing into that lifecycle, both at the JUnit low level, but also at the integration level, where we're talking about interoperability between systems, and that's what we're dealing with here. So that actually reduces risk around the performance of your systems. So the philosophy here is that we're introducing this technique of test-driven development into our development lifecycle. So how many people here are familiar with the Agile process? Okay, yeah. So I'm a Scrum Master. Also, I can put that up there on my certifications as well too. So I know exactly what you're talking about. So in an Agile world, we want to introduce testing as part of that cycle. Okay, so test-driven development asks the developers who are building that functionality to pass those test cases throughout the Agile lifecycle. So each short lifecycle requires the software pass the new test cases. Remember the Agile philosophy? After every sprint, you should have a deployable, artifact or implementation. Well, part of that is making sure that it's tested as well to make sure it passes the requirements. So I don't know if you've seen this diagram before, but this is like your Agile life cycle. You've got a backlog of things going on. You have your sprint, typically 2 weeks or so, and then you have a review process, and you start the whole thing all over. A lot of times when we think of testing, it's just kind of like this add-on that people think about. But really, we want that as an integrated process into what we're doing. So that's really what we're talking about with TDD. So that just kind of gives us a level set here on what we're talking about. Now, how does this actually work in terms of FHIR, in terms of our FHIR testing framework? Well, to ensure interoperability within the FHIR specification itself, starting with DSTU2, a FHIR testing framework was put into the specification. Now, testing has really been there for a while. I know that there were some resource types that weren't first-class resources. They were kind of buried in the spec to do testing. I know Graham was doing a lot of that internally. Those kind of got unearthed, uncovered, and when I was starting to look at this, and since testing is something that we do in my organization, I was really interested in this as a means to define how do we make an implementation agnostic description of tests that allow us to evaluate an implementation. So that's how the testing framework kind of got incorporated into the FHIR spec, is we kind of unearthed some of these things and then started evaluating them and realizing, oh, we need this here, and so the TestScript resource was born, if you will, along with all the things around it as well. So when we talk about the FHIR testing framework, really you need a test engine that's going to execute everything. And so the TestScript becomes that test definition, that computable, executable form of your test definitions. What operations are you going to perform? What asserts are you going to evaluate against that operation, and so forth. But from a framework perspective, the test engine, it has to do a few certain things. And this is taken from the specification, where we have a pre-processing phase. So we're going to evaluate the test script that you want to execute against the system to be tested. And we're going to evaluate your capabilities. Remember, for those that were in my intro, remember the capability statement? Remember, to be conformant to the FHIR spec, what? You have to have a capability statement that tells everybody else what you are capable of doing. Great, that's a computable resource. You can grab that from your FHIR system and compare it to the test script that you're going to execute. And we can make some determinations from that. So we can actually deny you running this test if you don't say you support something we want to test. Now, we actually don't do that because you may be in development and your capability statement may be behind and so forth, but we still want to let you test. But probably a better option would be to let you know, hey, we're going to run this test, but it doesn't match up with all the capabilities that so you may be lacking somewhere, but we'll still let you run the test. There's a setup operation, so in the test script there's a setup portion, so think again of your JUnit before action, so setting up the system under test so that it's prepared for what's going to come. So there might be some precursor operations. You may need to delete something that's there, you may need to create something that you need, that type of thing. Then after the setup, you have your test execution. So after setup, you have one or more test definitions that you're going to have, which are the actual use cases. So we're going to execute and record each of the operations and those assertions and capture all those results so we can report them back later. After the last test is executed, we have a teardown. So again, this is the after, right, from a JUnit perspective. So it's the cleanup portion. If you need to do anything to clean up what you've just done, because one of the rules of good tests is that leave the system under test in the state that you started with. Okay, generally that's a good practice to follow, right? And then finally, post-processing, and this is where the engine is going to clean up the execution data, collect everything, and then provide a report back of how you did. So each step along the way, we're going to provide that information back to you. Now, I've started a couple of these because I want to focus on these just to kind of drive this point home. I've talked about it a little bit where we have the capability statement of the system under test compared against the test script. So very, very simply, what we're going to be looking for is if the test script defines capabilities that the system under test does support, good to go. Off you go, start running things. But what if it does not support? Well, we need to have some mechanism to allow perhaps tests within the test script to be skipped or at least flagged that they're not appropriate. We shouldn't necessarily think of the results of this incorporated into the overall results maybe of pass-fail type of things. So we need these types of capabilities within the test engine. From a test execution perspective, this is really the heart of what we're talking about here. We're going to take an operation followed up by one or more asserts. So the operation is just the FHIR RESTful API. So create, update, delete, history, vread, patch, whatever it might be. Even the extended operations within FHIR as well Following that operation, one or more asserts. And the assert is the rule that will be applied against the result of that operation, the context of that operation. So think about the request response that happens in an operation, and the payloads that are retrieved, the HTTP headers, all of that information. That provides a context against which the asserts are going to evaluate. And so the asserts support things like XPath, JSON path based on your syntax. We also do FHIR path and so on. So we can do very interesting things with the asserts. And I'm going to talk about that more tomorrow in the advanced session, getting into some more detail like that. The key concept here to remember is that if you define an operation in your test script, the test engine will execute it. Okay? Whether or not there's an assert after it. So why is that important? Well, think of it this way. Without an assert, you're not really testing anything, are you? So it's important to have at least one or more asserts after your operation, because that's really what you're doing. What's your use case, right? I want to assert that my read operation sends back an HTTP response code of 200. It's okay, right? Or I might actually be testing a negative case, right? I expect a 404 not found. Again, it depends on your use case. So the result of the test is dependent upon the assert. What are you asserting is going to be true in order for a pass condition. So it's interesting, we can test failure conditions and pass them, right? It's negative testing. So it's just an important concept to keep in mind. So a little bit more about asserts. Again, as I mentioned, they act on the current operation's execution context. It states a condition, rule, or expression that's going to be evaluated against that context. Once the next operation executes, that operation context is replaced, right? So you lose the previous context, and then you move on to the next operation context. Asserts provide support for evaluation. As I said, the request-response exchange. Complex and simple evaluations, HTTP headers, response codes. We have different operators for comparison and conditionality, that type of thing. Expression language support, payload, validation. One of the key concepts with the FHIR test engine is that you need to incorporate the FHIR validation engine. Everybody know what I mean by that? FHIR validation engine? Okay. You know what a profile is? A structure definition, right? Anybody over at Michelle's presentation for profiling? Okay. What is a profile meant to do? It's meant to define the constraints on a particular resource type. Well, how do I know that the payload of, let's say, a create operation is conformant to a particular profile? Well, I have a validation engine that will take that profile and apply it against that instance of the resource in the payload. We've incorporated the FHIR validation engine that comes with the FHIR specification as a service to our FHIR test engine. So the assert can actually make a call to the validation engine, and we can get back all of the information about that validation process. Again, based on the base profile for the spec, or on individual or additional profiles that you say your resource is supposed to be conforming to. So there's a lot of fun things you can do here from a testing perspective to validate what's going on. So with that, I'd like to introduce Touchstone. And Touchstone is our publicly available cloud-based testing platform. So testing as a service. It provides automated internet-based interoperability testing for the FHIR specification, leveraging TestScripts, as we've talked about already, which is really how we do test-driven development and natural language processing. So think of the test script as that document, but it's an executable document that can be processed and executed. And we're going to take a look at some information about that, more information about that as we go on. So Touchstone itself, and I don't know, I wasn't at Vadim's presentation. Did he talk? He talked about tooling, right? I don't know if he mentioned Touchstone or any of the other types of tools, but yeah, probably save that for me.
He did mention it, yeah.
That's okay. But here's the landing page. So basically, if you go to touchstone.com, it'll redirect you to our main landing page here. And the idea is that this is just going to give you some basic information about Touchstone. So we've got like an alert section up here. So as you know, if something important needs to be expressed about the tool, we'll give it up here. We've got some nice information. We have links into our online documentation. So we have a user's guide and so forth that you can link into. I have feeds here that I like to keep updated, so if there are any blog posts out there, especially the ones that I do, I like to list them here, so you have links there to that. But I know David Hay has his blog post and so forth, so I like to put links up there when they're related to testing, things that we're doing. So the landing page is the first place you're going to do, or end up. And the thing about that, let me just jump back real quick and point out test definitions. Okay, so there's a menu over on the left side with one item. That's because you're not logged in yet. So you have to register an account and be logged in or signed into Touchstone before you see anything else in terms of functionality. But the one thing that we do want to show you that you have access to is all of the test scripts that are deployed in Touchstone are available for you to look at, even if you're not logged in. So we're not trying to hide anything. We're not trying to actually, hey, we've got these secret little test scripts over here. We want you to know what they look like. This is what is going to be executed against your test system. And so we want you to be familiar with them and know what they're going to do. So if you click on test definitions, you'll get the test definitions page, and it's going to be just a big listing of all the test scripts that we have deployed. The test definitions menu will turn into like a little tree view, like a folder structure, how we've organized all the test scripts. So we'll take a look at that in a little bit. So to get started, as I mentioned, you have to register and accept our user agreement, and you're going to play nice with everybody else, right? And then every user must belong to an organization. So we don't just have single user accounts, you actually register your account with an organization. So if you belong to Cerner or Allscripts, or if you have your own company, or even if you're just all by yourself, just come up with an organizational name. If you're part of a larger organization and somebody else has already registered that organization, you can simply request to join it. And so there can be multiple users within an organization. Now, based on subscription level, you'll be allowed access to multiple users and so forth. So we have like a starter program where one user, one organization, that type of thing, and so on. So the user registration page, simple. Give us your name, that you want to be known by within Touchstone. Valid email address, because we have to notify you of things when things happen, especially like that you've registered. And your password, and make sure you're not a robot. So just check the CAPTCHA there and you're good to go. Okay? Well, once you're registered and you've got an organization, it'll prompt you to join an org or create a new one. You then need a test system, right? So how many people here have actually started building or are building a FHIR server or client? Okay? So we've got a couple, good. So when you come here, you're going to want to run your tests against probably your server, right? Or your client. We can do client and server testing by the way. So Touchstone can act as a proxy that'll sit between the client and the server. But you'll need to give your test system a name, what the base URL is for the server. The IP address you can leave blank. We'll discover that for you, what your public IP address is. And then this is if you're an admin. Like if you're not an admin, you're not going to get to choose which organization it belongs to. It just belong to your org. But we also have some privacy settings here, which is kind of important. One of the things you'll find in Touchstone is that a lot of people who've registered test systems in Touchstone already have made their test systems public, meaning that you don't necessarily have to have a test system to start with. Okay? So if you want to use my Wildfire server, my public Wildfire server, it's publicly available. You can run any test script you want against Wildfire. And so when we go into test execution, you can just choose that as your system to test against. Well, that's great for me. I like when you test my system, but it's really more for your systems. So when you build your system, go ahead and register it, and that'll become available. But from a privacy perspective, notice that I've set up everyone here as viewable. So everybody can see it, but there's another level. Who can execute against it? So for me, I set mine to everyone. That means that you can both see it and execute against it. But a lot of times you may want to just simply hide your test system. You don't want anybody else to touch it, right? Because you're the one that wants to do the initial testing against it. So we can hide those systems so nobody else can see them until you're ready to make it. And you can come back to this screen and change your settings whenever you want. And then we have some basic profiles here. Early on, we were looking at the structured data capture profiles, and so we've kind of listed them here. But generally, FHIR Client and FHIR Server are the two main profiles that we're going to be playing. Okay, you've got a test system. How do I run a test? Well, you're going to choose one or more test scripts. So remember that navigation under test definitions here? So here's what that folder structure might look like. So I've already built a bunch of things for the basic types of tests, create, update, delete, that type of thing. And I've organized them by resource type alphabetically. Okay, so I'm going to choose patient after I drill down, and I've got 1, 2, 3, 4 flavors of test scripts for the patient resource, just doing basic create, update, delete type of operations. And the variations here are based on JSON versus XML, or client resource ID versus server resource ID assignment. So if you know what that means, great. Otherwise, the tests are all the same. So I can just choose whichever one is appropriate for my server. If my server supports everything, I can just choose them all, right? But then, most importantly, you have to create a test setup. And this is just a paradigm that we've done within Touchstone for automating these tests. So the test setup is going to be a collection of one or more test scripts, and then you're going to give it a name, and when you save that, you can then go back and re-execute it based on that test setup name. Okay? But let's say we've filled it out, and we've hit execute after we do that. When you hit execute, you're going to go to the test execution dashboard. So here you see a running test where I've actually selected all 4 test scripts. So I have a suite of test scripts. Each test script is like a workflow, if you will, going through the process. And so we're going to give you some diagnostic information as you keep going on here. Here we've completed the first test script. Looks like we're all green here. Notice the second one is now in a running state. And over here you can see some other data about how things are going on. The page itself doesn't auto-refresh. Okay, again, just from keeping track of things, auto-refresh kind of interfered with a lot of stuff that was going on the page. So just do a manual refresh or a browser refresh, and then you'll get the updated results. Keep doing that until you run to completion. Basically, you've got 28 tests in total. Each test script had 7 tests in it, so 7 times 4. 9 so far have passed, and we have 1 running, right? And 18 have yet to be started, and our current success rate is 32%. And as we continue on, right, we're going to see more and more results. Now, I'm more interested in drilling down into a specific test script itself and seeing what the results look like. So here, I've clicked on the first test script, and now I'm looking at the details of an individual test script and the tests within it. Again, some dashboard information telling us some nice, lovely information. But up here, remember the capability statement in the test script? How do we match those up? Well, here is a summary of everything that my test script is going to test. Test script is computable, just like any other resource type. So we pull out of it all of the operations that are being performed against all of the resource types. And we give you a nice little graph up here, or a table, that tells you how you did. I did pretty well. But the idea here is that I can see where I have passes and failures broken down by operation and resource type. And if you drill down even further, you can see the information details down here as well too. Now, the test steps, okay, so the individual tests, are also expandable. So the interface keeps expanding down into more and more detail as you need to find things. Typically when you have a failure, you want to drill down and see more about what happened. We also have links right up here to the test script definition itself. So as I said, test script is a FHIR resource, right? So here is test script, the resource ID for that test script in a FHIR sense, and then some of the things that you'll see there, but it's all there, so you can actually see exactly the definition that is executed. Let's take a look at a drill down now into a test. So here's an example of a read operation that failed. Well, did the operation fail? The operation actually worked, meaning it did what it was supposed to do from a FHIR specification, right? So I tried to read a resource that didn't exist. 404. What did I expect? What does the assert say? The assert is what's going to cause the failure to occur. So the assert, the actual value of 404 did not match the expected value of 200. Right? Very, very simple in concept, but something you have to realize is that the operation is going to do what it's going to do. But based on your use case, what are you testing for? Okay, so that's where things get more interesting when we start building out those asserts. Okay? And we actually echo back, so we've echoed back what that description of the assert looks like within the test script itself. So there's our description, there's the response code that I'm looking for, and the direction is response. So I can test both request and response sides of the operation. If I don't specify direction, by default I'm going to test response. So we had to come up with some defaults that made sense. But you can see, if I change this to be request, I could be testing things about the request that happened. Well, look at all the information we're capturing and showing you about that operation, right? So here's the request, and Touchstone is generating the request in this particular case. Okay, so Touchstone generated the request based on the definition of the operation. So I did a get on this path, and it didn't look like I had much else going on there from a request perspective. Again, because Touchstone did it, I'm not as concerned about Touchstone. I'm not going to test Touchstone, but I do want to test the response. So we'll capture everything about the response, including the payload and the body here. It's all linkable and clickable, and you can pop those up and see all the details you want. Yes?
So how do you initiate a request from the test system, like the...
So an external FHIR client. Right?
Yeah.
So come to my advanced session tomorrow, we'll do a demo. Okay? Or you can come over to the FHIR testing table this afternoon for the hands-on, and I could probably give you a quick demo there as well too. Because remember, Wildfire is also a client. So I can use my Wildfire client and execute an operation from my Wildfire client to another server, but I'll go through Touchstone and it'll capture everything. Okay? Another interesting thing about the platform is that it's really an analytics engine. So we fielded Touchstone a little over 2 years ago now, October of 2015. We have, was it over 400 or close to 500 organizations or users? I have to look at the statistics. But if you think about it, we're collecting data on all the tests that have been executed. So we're storing all that information. So there's a lot of analytics that we can do on that data. Now, we're not publishing any of that data. Our purpose is not to, hey, look at those guys over there, or look at those guys over there. Remember the privacy settings? So part of the user agreement is that we agree that we're not going to publish your results. Okay? If you want to keep them private, they're all yours. Okay? But we don't publish results, and there are some white papers we might be involved with where we're talking about testing. If we want to use any of your data, we will contact you to get your permission first. I just want to make that very clear. Okay? So we're not in the business of announcing to the world how you're doing on your testing. Okay? This is a service to you. Okay? But one of the neat things is that we can take a look at things like your conformance to the spec. So this is a little view of all the test scripts we have for FHIR 3, STU 3.0.1. Okay? So I've got a set of advanced test scripts that really test the API. I've got those basic test scripts. I've got connectathon test scripts. So at the connectathon, we've been fielding test scripts for the various tracks and so forth. And collectively, when you run those tests, we're gathering how you did. Okay, are you green, are you red, you know, and that type of thing. So we can aggregate all that and we can see how well you're doing overall. And so 81% is how well my wildfire server did. Okay, am I really at 81% though? That's a good question. Well, notice I have some gray here. I didn't execute any of those tests, did I? They're gray. Right? It's either going to be red or green if I executed something. Well, I have a red in here. Well, these particular tests from the Connectathon are something I don't support. My capability statement says I don't do terminology. Right? I don't do those tests. Well, okay, am I really at, I can show you that later. I can probably dive into that. But if I were to go back and check the little box right here, exclude unsupported, it means I'm now taking into account my capability statement, and I'm going to filter out any tests that I'm not capable of doing. Even though I may have executed them, I'll filter those results out. Okay? And so I might be at 100% based on my capability statement. And that's really the more important statistic. Another way to look at this is through the test execution history. So again, we're keeping a history of everything that's been done. Because, you know, oh, last month I ran this test. How did I do? Or you know, what were the results? So you can go back and you can filter based on test system, your organization, and so forth. Even by status, you know, just show me all the ones I failed. You know, and then I can drill down into those. I can even do things like executed just by me, by members of my organization, with my org if your server is public, or by everyone, which is an admin role that I have. So, question, has this happened to you? The development team's been working to deliver their implementation, the QA team is ready to go, and you ask the developers, is the app ready? Developers say, yes sir, we're ready to go. Well, reality sits in. QA team starts running and issues start popping up all over the place. And you realize the development team really hasn't done a thorough job of testing. So the real question here is, anyone can run a test and say if a system is passed and failed. How do you know for sure? So Touchstone is a way to provide that information to give you the assurance that the tests have been run and passed. So you can even, the developers can hand it off to the QA team with their results. You know, so think about it. The developers can say, here are my results, and the QA team then has a nice level of confidence going forward. So the continuous testing paradigm here allows us to look at patterns, look at predict trouble areas, pinpoint issues in development before they make it all the way to the QA and even staging cycle right before pre-production, that type of thing. This is a real-world example of where we asked an organization if we could publish their results. So this is real data, and the graphs here represent testing activity and how well they were doing. So in this case, the organization, even though I got their permission, I'm not going to use their name. They went to the Connectathon event. This is by week, so week 5. So this is the January Connectathon of this year. And they brought a FHIR server and did a whole bunch of testing during and after. They realized, well, we weren't passing everything, so let's do some development. Then they came back to Touchstone and woo, they did a lot more testing. And guess what? They now at 100% of passing on all their tests in Touchstone. Another way to look at that is, here's the number of tests, number of passes, number of tests, number of passes until they match. So it's just a representation of data, but they're using that test-driven paradigm to help them move through and find problem areas and identify them so that they can correct them. So, I know I'm running short on time here. I think I'm down to a couple minutes. So let me run. Yeah, okay, all right. And then we have lunch, right? So if you're not real hungry, I can keep going, right? So first and foremost, we can help you with conformance testing. Okay? We maintain suites of tests for different FHIR versions, basic, advanced, and again, Connectathon, as we've seen. We can allow you to share those results, keep them private as you see fit. but it provides the opportunity to validate on a conformance-based methodology on how well you're doing. Okay? So we can help you with that. We can also help you doing your software build cycles. One of the key aspects that we built into Touchstone is there's an API, a lightweight RESTful API that you can leverage to integrate Touchstone testing with, say, a CI process. So if you're building your FHIR server and you've got like a Jenkins CI build process going on, you can actually integrate Touchstone into that build cycle as well. I've actually done that with Jenkins with Wildfire in my local environment. So I have a Jenkins server where I can build Wildfire, and then I actually link to our QA development for Touchstone, or QA environment for Touchstone. Okay, so going forward, well, wouldn't it be great if you could build your own scripts, right? Everything you see out there in Touchstone right now is something that I wrote. And how did I write them? TextPad. You ever do XML in TextPad? Okay. I tried XML Spy, some XML editors, but I just actually found it easier just to do, because you end up doing a lot of structures that repeat over and over again. So TextPad has become my editor of choice. Well, really what I'd like to do is have a TestScript editor. And that's actually where we're going. We're working on something called the Touchstone IDE, which will be an integrated environment that will integrate to Touchstone so you can publish your own test scripts as well as write them and edit them yourself. So we're hoping to have that available early next year. So I've got a developer kind of figuring out a lot of that stuff. We're actually going to use Eclipse as our IDE base with plugins. So you can actually link up to repositories like GitHub or Subversion. And we're even looking at Simplifier as a repository for test scripts that we can link up to and publish right from there up in the Touchstone. We also offer additional training. So what I'm showing you today is what's based on some of our multi-day tutorials and training that we offer on this as well. So with that, I'd like to leave you with hands-on exercises that if you want to come by the FHIR testing table, and I noticed they strategically placed my table right next to the bar. Okay, so I'm very happy about that. But we've got some basic tests to get you started to register and set up your test system. Also starting up with doing some test setup and execution, just some very simple tests. So I have a little suite of test scripts I've written just for DevDays for these exercises that you can start to execute and get a feel for how they work. And you can use Wildfire as your test system if you want, if you don't have one of your own. We also have a challenge. So at the next January HL7 working group meeting, there's this FHIR Connectathon, and they have all these various test tracks at the Connectathon. I would like to challenge any one of you to help me out, and let's start writing test scripts for one of the Connectathon tracks where we don't have them yet. So if you're interested in figuring out how to define a test script and relate it to the tracks at the Connectathon, I'd love to have your help or input. And so you can talk to me more about that when we get to the hands-on section this afternoon at our table. And with that, I know we're kind of short on time here, but any quick questions? Yes?
Do I have to have a public server available, or can I test it against the locally running?
Yeah, we get that all the time. So right now, because it's a cloud-based environment, you have to have a publicly accessible server. So you have to have a public IP address, essentially. Now, we do have options for doing Touchstone in an on-premise environment, but that's going to be a licensing thing and so forth. So the real issue is, if I got a server on my laptop and I'm stuck on a Wi-Fi behind a network firewall, how do I expose it? Right? I mean, if you can do that, great. Then Touchstone will be able to talk to you.
Yeah.
Okay. Otherwise, you'll have to have like a local deployment of Touchstone, and Touchstone is not something simple to just deploy. Okay, because there's a lot going on under the covers. Okay.
Those test scripts, these are all standard scripts that you have provided.
I've done the authoring of probably 99% of the test scripts that are out there.
So they're basically just testing all the functionality of
Right.
the FHIR interface.
And so I've done basic ones, which basically do create, and then I make sure I get a correct 201, and then I make sure that the payload is validated. So I keep the asserts minimal on the basic tests. The advanced tests for the API level testing, I really cranked it up, and you'll see like a ton more asserts because I'm checking every little aspect I can unearth in the FHIR spec. Okay, so how many different ways can you do an update? Right? Well, there's conditional updates, and do you support versioning? So there's a lot of conditionality in the spec that you need to account for when you're writing these asserts. And I talk about that more tomorrow in the advanced session that I have. Anything else? All right, well, thank you. Enjoy lunch.